Draft physics video. Kind of a new category. Let's call it the ecology of physics. Kind of in the theme of the circle of life kind of stuff. Maybe I could draw it. So I'm sort of arguing that these things, okay, you have gravity, let's say, at the top, and that slides into magnetism, and that slides into electricity, and that slides into photons of different kinds, all the radio waves and microwaves and cosmic rays, the different rays. And in a sense, if you think about those photons having a termination in the bigger, wider universe, they could just be reflecting back as gravity again. So again, if you understand that the mechanism is made out of something that is doing this cycling, and Richard Feynman gets to this in a lot of his lectures. I've said in the past that it seemed to me like he was very close to saying what I'm saying, in the sense that he was very close to the same kind of metaphors. He used the checkerboard metaphor once and talked about maybe the whole thing is really, really simple. It's just that there's so many checkers that you can't see the simplicity. Because there's so many things happening on the checkerboard, it's too big. But what's happening is really simple. You just see the big patterns. But the mechanism of jumping is just jumping. That kind of thing. And there's a collection of these videos on who was apparently some sort of fake guy pretending to be a journalist. People are pretending to be everything. I mean, he took the icon of a guy who's a conductor, and this is kind of bogus. And so, yeah, it looks like his name is Bitcoin Facets now or something. Well, maybe this video was in the favorites of the guy who's the fake. Yeah, the playlist of John Adams, right. So John Adams appears to be a fake. But anyway, doesn't really matter. Well, what matters in a sense is just it'd be nice if there were some humans on Earth, just some decent humans. But no, can't find any of those. It's a difficult struggle. Anyway, so there's one video where it's a collection of bits. This is kind of later in Feynman. I don't think he was, I think it was, not sure if he'd already been diagnosed with cancer. I'm not sure if this was before or after that. But anyway, they're kind of interesting. And one of them's the magnetism thing where he goes on a spiel, and that's in here. So I'm going to play some of that and some of this other stuff and just get to this point of, Feynman was very good at talking about imagination and how important it is. But if you go back to his 30-year earlier lecture where he's so casually dismissing imaginative ideas because they don't fit in what he has accepted, in the box that he's in. And so that's a sort of disappointing, because you can kind of get the idea that he knew to be humble, but he really wasn't. But you can see that he had the knowledge that it was the right thing to be, and he was just human like the rest of us, and tripped over the implementation. But you can hear in the themes, like some of these conversations about the whole oxygen cycle, and talking about the carbon cycle, I guess the oxycarbon cycle, and just how it completes an energy cycle. And then he talks a little bit about going to the dentist and thinking about the drill, and then thinking about the fact that there's a turbine out there somewhere spinning just like the drill, and that what's really happening is the spin is being transferred from one place to another, this motion, and it's just movement that's being transferred. Like I said, ideas that are very the kind of stuff that many of the people who are arguing with me don't have much respect for, but this sort of logical intuition, this kind of fundamentally, you can see these patterns in nature and in the function of things, and recognize that the fundamental elemental nature probably follows the same kind of patterns, and that when you create theories that are dependent on things completely abstract, completely foreign to that simplicity, you're probably going the wrong way. That's probably not the right answer. The right answer probably is something that has this symmetry to it, that has a round wheel completeness to it. Alright, so that's probably enough of a preface. So on with some of the show. I don't think I'll speed it up, just, you can take it. Feynman's an interesting character. It's fun to watch.
Why does water expand when it freezes and other substances don't expand when they freeze? All right? I'm not answering your question, but I'm telling you how difficult the why question is.
Right, so it was asked why magnets attract. And then, so this was a part where he sort of went on to other things and he uses this word attraction. And it's kind of funny because he talks about push a little bit and jiggling. But he still thinks in terms of, but gravity's an attractive force. So he says those words, right? I've gotten some comment from some people who say there's nothing explicitly stated that bent space is an attractive force, but Feynman certainly thought of it that way, and that's the point. Most physicists think of it as attraction. They don't think of it as the absence of push, the absence of a pressure, and that the pressure still exists on the outside. So that's a real phenomenon. So in this segment he was asked to explain magnetism, and he's really explaining why he can't explain magnetism. First, because it starts to get kind of complicated, because it is in these layers of cause and effect. And more fundamentally is because, yes, physics doesn't have that answer yet. They don't have it. Some people have it.
You have to know what it is that you're permitted to understand and allowed to be understood and known, and what it is you're not. You'll notice in this example that the more I ask why, it gets interesting after all. That's my idea, that the deeper a thing is, the more interesting it is. And
okay, so again, sort of a concept of interesting, probably in the sense that you think you're getting somewhere. And I'd say that if we both agree that that's what interesting is something that looks like it has there's fruit there to get. There's something to pick. And physics just lost its ability to pick it because it created these two rigid theories, the wave function in quantum mechanics, the probability function, turning the small things into just mathematical formulas, and in the big universe, killing the force of gravity by turning it into a bent structure of unknown origins or mechanism. And those two, what I will call mistakes, and they're both similar mistakes in the sense they're both over-reliant on formulations that create solutions to problems rather than formulations or descriptions or models that enlighten us as to function. So, I mean, understanding what something does and understanding why it's doing it, they kind of lost sight of the question, why?
we could even go further and say, why did she fall down when she slipped? That has to do with gravity. It involves in all the planets and everything else. Never mind. It goes on and on. Now, when you ask, for example, why two magnets repel, there are many different levels. It depends on whether you're a student of physics or an ordinary person who doesn't know anything or not. If you're somebody who doesn't know anything at all about it, all I can say is that there's a magnetic force that makes them repel. And that you...
Okay, a magnetic force that makes them repel. And then for the physics student, though, his explanation is going to be is this force is not a generator of energy. So although this force has impact, there's no accounting for the energy creating the force. The force is something where it can just merely be suggested, essentially. The magnet essentially suggests the idea of shooting rays at the other magnet, rays that it finds repulsive, and the other magnet shoots back rays that it finds repulsive. But it's just an idea that it just suggested, just like the sun somehow suggests to the earth that it should obey some geometric laws or rules and slide towards the sun. So instead of a mechanism to explain what is an obvious energetic happening, in the sense the earth moving towards the sun, the movement is significant, the alteration of its course is significant. It would require, if some other force had to do it, we would all recognize it as a significant force, a gigantic flame shooting out of the earth away from the sun, pushing it into the earth. We know that would be a significant force that would have to be applied. And in magnetism, they have the similar problem where they don't have a method to transmit this suggestion to electrons to move. Somehow they move, okay, because something told them to. And, the argument would be, yes, it's the magnetism that told them to, but how did the magnetism create what had to be a force? Because again, if you wanted to create the electricity some other way, it involves somehow propelling a bunch of electrons down a conductor, and that requires energy. So again, they broke the energy cycle by taking gravity out of the energy equation, and therefore you can't use it when you filter it to create magnetism and electricity. So it's just such a simple breakdown of the cycle. They flattened the tire at the beginning with wrong premises and axioms, and they'll never be able to make it round as long as they stay glued to these wrong premises.
Feeling that force. And you say, but that's very strange because I don't feel kind of force like that in other circumstances. When you turn them the other way, they attract. There's a very analogous...
So again, you use the word attract. So, obviously what I'm arguing is the gravity is this photons, essentially, but without any frequency. So they're just tons of various distances from each other, coming in streams. Nothing you could glean out of it as a consistency. Where photons are these tons at very specific distances. And then magnetism is the tons, but at strict polarization. So there's two types of gravity, black and red. We'll just use this example. And the black ones are the ones relevant to electrons, and the red ones are relevant to protons. And they behave two fundamentally different ways. When the particle of the same type hits an electron, it's a perfect reflection. So it just bounces back and forth between the electron. And that bouncing back and forth means as you bring two electrons closer together, you create more and more impacts, which is more and more energy. And when you put more ping pong balls in, obviously you would create more energy. And the same is true for the proton. And then when it's proton and electron, both of them, the forces leave perpendicularly of opposite polarization. So the proton releases black tons perpendicularly, and the electron releases red tons, or proton quanta, perpendicularly, which just drains all the energy between the two of them, and then the external energy then forces them together. So it's always a push. All action is a push. It's all pressure. So in a sense, Ken Wheeler is correct in that it's all pressure mediation, but the pressure is something real, not just some idea of poking a gelatin ether that you have to still account for. And you have to account for the fact that it doesn't move, where these little bits contain energy, one quanta worth of speed of light energy in a direction. They can create pressure, and ether, by standard definition, doesn't contain any pressure innately.
Force, electrical force, which is the same kind of a question. And you say, that's also very weird. But you're not at all disturbed by the fact that when you put your hand on the chair, it pushes you back. But we found out by looking at it that that's the same force, as a matter of fact, the electrical force, not magnetic exactly in that case.
So he said it's not exactly the magnetic, but that sort of is the argument. He also will say later this exactly almost the opposite, that the electrical force is a consequence of this magnetic force. So clearly the magnetic force is the only one that's a force. Electricity is just the phenomenon of electrons moving. What happens when electrons move is they create this perpendicular energy, this perpendicular flow, and that field energy coming off, that's the EMF. That's the magnetic flux, essentially. Force. That's the way the electron reveals its magnetic nature, in the sense that it's creating the same thing that a magnet would create, which is a force of one polarization. Only the reds come out the perpendicular way. The proton heavy force. And likewise for the protons, as they move the opposite way, essentially by consequence. If electrons are going one way, protons are realizing the change, in the sense that the electrons are moving, so relative to them there's a change, and that change will likely produce in them also a release of force. Yeah, I don't know if I need to get into great detail on that, but anyway. Moving on.
But it's the same electrical repulsions that are involved in keeping your finger away from the chair, because everything's made out of its electrical forces in microscopic details. There's other.
Okay, so it's not electrical, it's really magnetic. And I think that's something he should have, I mean, yeah, he's doing it from his comfy chair, so, but I think if you probed him, he would concede that the pressure between the elemental bits is more likely a magnetic pressure than anything called an electrical pressure. There's no real thing, there's no such thing as an electrical force. There's only the consequence of the movement of electrons and the force that has to exist to move them. That's the electrical force contains the quanta. The quanta are what the electrons are essentially being, it's the river the electrons are floating in. But the elemental bit is the river, not the electrons. And the elemental bit is magnetic.
Forces involved, but this is connected to electrical forces. It turns out that the magnetic and the electric force with which I wish to explain these things, this repulsion in the first place, is what ultimately is the deeper thing that we have to start with, we can start with, to explain many other things that looked like they were, everybody would just accept them,
So this is sort of the ironic part, where he's going to almost say, this is the elemental bit, and this might lead to some better understanding of gravity, when, well, gravity's the more elemental expression of this force, in the sense elemental, in the sense that it's the part that's not filtered. It's the part that isn't at a frequency. It's the unsophisticated, raw energy, where magnetism and photons are augmented, are enhanced version of that force.
You can't put your hand through the chair. That's taken for granted. but that you can't put your hand through the chair when looked at more closely. Why? It involves these same repulsive forces.
Right, repulsive forces. And so there he gets the repulsive part, and the part that's the strong force. That's really as strong as you get, because you can shove those electrons closer and closer, and as you do, those reflections get faster and faster and faster, and that means there's more and more of them hitting the two bodies, and each hit is the same, whether it's a long, whether the ton traveled a long distance or a short distance doesn't make any difference. It's exactly the same force. So every impact is just counted as an impact, and there's no half impact or quarter impact. So it's much more energetic. When you push the electrons closer and closer, it just gets stronger and stronger and stronger. So that repulsive force is the one that makes brick walls brick walls.
That appear in magnets. The situation you then have to explain is why in magnets it goes over a bigger distance than ordinarily. And there it has to do with the fact that in iron all the electrons are spinning in the same direction. They all get lined up. And
okay, so I would argue that it has nothing to do with how they're spinning. It just has to do with the orientation of the electrons and the protons, and the fact that the atoms are essentially creating miniature magnets, miniature filters for the force, meaning more red stuff goes this way, more black stuff goes this way, and less red stuff goes this way, and less black stuff goes that way. And so they're filtered, which is concentrated. And so when you put two magnets next to each other with their concentrations maximized, you'll either get the effect of the proton on electron, which is all the force escapes, or you get the electron on electron or proton on proton effect, where the reflections get stronger and stronger and stronger, and there's no escape. They can't. There's no pressure valve to relieve them, so the impacts get more and more numerous, and the pressure grows higher and higher.
they magnify the effect of the force until...
Okay, so magnify the effect of the force, where my version, my simple little correction to Feynman would be, no, they filter the force, and that magnifies the effect of the force. Filtering. Without the filter, there's nothing. The filter is the magnifier. It's the lens that makes a magnet capable of turning plain gravity into a very powerful force.
It's large enough at a distance that you can feel it. But it's a force which is present all the time and very common, and is in a basic force of almost, I mean, I can go a little further back if I were more technical. But
right, so see, he's creeping at the subject, but he knows that he doesn't want to go there, partially because, yes, then he has to start talking about virtual photons. But he knows it's a fundamental force in the sense that he knows this is what holds atoms together. This is what holds electrons to protons, that they're actually the ones doing the filtering of the force.
on the early level, I just have to tell you that's going to be one of the things you'll just have to take as an element in the world, the existence of magnetic repulsion, or electrical attraction, magnetic attraction.
Electrical attraction, magnetic attraction. Like I said, there's only one force. It's gravity, right? And then it's turned in, when it's filtered, it's magnetism. And there really isn't any electrical force, because the magnetic force is what's really moving the electrons. So he'll say it here, that the two forces are very similar and they're blended together and all that. So he does understand that, but again, there's no such thing really as electrical attraction that isn't really a manifestation of a form of magnetism. Charge is a form of magnetism.
I can't explain that attraction in terms of anything else.
Charge is the recognition of a filter. So when they say an electron has a charge of 1, and they say the proton has the same charge, that just means that's how much of a filter it is. It's a filter of 1. If it was a charge of 4, it would be a 4 times stronger filter, like a 4 times stronger magnet. So its charge is just acknowledging how much something filters the stuff that comes into it and segregates the black from the red, creates polarization. And in electrons and protons, clearly you have monopoles. The neutron is essentially a dipole, probably, but these are the only monopoles in existence. The rest of them are all magnets, in the strict sense. But the proton and the electron are really magnets. They're just in this unusual configuration where they're independent of their opposite pole.
That's familiar to you. For example, if we said the magnets attract like as if they were connected by rubber bands, I would be cheating you. Because they're not connected by rubber bands, I shouldn't be in trouble.
Right. And this might be a good time to point out that some of these other explanations are much like that. Bent space is pretty much a rubber band excuse. It's just kind of putting off the answer and blaming it on something else. Just saying, we don't know, so we'll blame the geometry, the magical whatever, ethery, slidey stuff that Earth has to obey, has somehow created a mechanism that obliges Earth and all of its nuclear bits to obey the rubber band. But there's no physics. There's just a geometric model of a law we already knew existed, the inverse square law.
You'd soon ask me about the nature of the band. And secondly, if you were curious enough, you'd ask me why rubber bands tend to pull back together again, and I would end up explaining that in terms of electrical forces, which are the very things that I'm trying to use the rubber bands to explain. So I have...
So again, he says electrical forces, but they're really magnetic forces. They're forces of adhesion and stuff wanting to stick to other stuff. And it can't stick when it's warm, and so the rubber band, the long molecules are able to contract.
Heated very badly, you see. So I'm not going to be able to give you an answer to why magnets attract each other, except to tell you that they do.
Okay, so see, so he says attract each other. And I'm just saying this is physics, and they've had to deal with this for a long time. This function of attraction, and it's it just reeks of the absence of pressure. I mean, if you think about all of the things that create any kind of attraction, like the crushing of a can, you put a pressurized can in cold and it crushes. The pressure from the outside crushed the can. It wasn't something inside that crushed the can. It was the fact that there's pressure on the outside that crushed the can. Just like with us and the air pressure, and you take away, put us in a vacuum and we expand, well, to some extent. What we do is boil, but it doesn't really matter. Don't need to get into those complex arguments.
And to tell you that that's one of the elements in the world of the different kinds of forces. There are electrical forces, magnetic forces, gravitational forces, and others.
Okay, so electrical, magnetic, gravitational forces. And again, all of these forces, these physicists have dealt with, they have so many things in common. The speed of light, the inverse square law under many circumstances, the capacity at least to be compliant with the inverse square law, the fact that all these radiations seem to radiate following straight line rules. They tend to go in straight lines. And they don't interact with each other.
And those are some of the parts. If you were a student, you'd go further. I could go further. I could tell you that the magnetic forces are related to the electrical forces very intimately. That our relationship...
So, again, that's something, now he says it, so he understands it, but he doesn't use it in the rhetoric, because the tradition is to keep these things, is to be fooled by appearances. Just as we're fooled by the fact that visible light, we can see it. And so we don't think about radio waves being essentially the same kind of transmission. It's just that we don't see them, you know. But it's the same kind of time. And we can think of other kinds of radiation, like X-rays, so much more intense. You know, hundreds, I guess it's thousands of times higher incidence. You know, the guns firing thousands of times faster. You know, in terms of the bullets, the rate at which they're fired. But it's all the same thing, and it's just some silly circumstance of what our eyes are capable of being tuned to because of chemistry. There's no chemistry to take advantage of X-ray vision. No chemistry that is survivable. If we shot X-rays and then saw them bounce off things, we would end up killing each other with our X-ray vision, you see.
Between the gravity forces and electrical forces remains unknown.
There. No, not anymore. And a theory that would be the first step to keeping gravity in the physical realm as a source of energy was something you helped throw out. So again, just keep that in mind, that Feynman is cited as some sort of important player, even though his argument was superficial against a particle gravity. And, you know, he concedes their answer isn't an answer. He said unknown. This is well after Einstein's been established as bent space is the answer, general relativity is the answer. Yet he said gravity's unknown because he knows it's not an answer. It's a placeholder for an answer.
And so on. But I really can't do a good job, any job, of explaining magnetic force in terms of something else that you're more familiar with, because I don't understand it in terms of anything else that you're more familiar with.
Right. So let's understand. He made a whole argument about particle gravity and its failure by comparing it to raindrops. So he took something very familiar and forced something that didn't have to be anything like a raindrop, that wouldn't behave anything like a raindrop, and forced it to take that identity. So it works both ways. Here he is searching for ways of explaining the transmission of a simple idea of a force, a push. We live in a, he concedes, he's famous for talking about the fact that everything's jiggling. Well, what's jiggling it? You know, that's the force. And it's a dense and thick. The universe is thick with it. And conventional physics has taken the thickest part of the energy gradient in the universe and turned it into some sort of geometry that isn't part of the physical universe. And it's a huge error.
This stuff of fantasizing and looking at the world, imagining things, it really isn't fantasizing because you're only trying to imagine the way it really is. Comes in.
Right. So that's another part where you'd say, in challenging your own imagination, there has to be some sort of guidelines for that imagination to be fruitful. There's got to be some point where you say, okay, talking bears would be nonsense. You know, things that hatch from the golden eggs laid by the Jolly Green Giant's goose, you know, that's going too far. There has to be some sort of limits. And, you know, and again, there's these simple rules that of symmetry that constantly re-arise in the function of the universe. The wheel, the recycling of the energy, the fact that there is no free lunch, so that the system of your forces should have some kind of circularity, some sort of, the fact is that it doesn't matter where I turn this wheel, okay, it's always gravity, magnetism, electricity, photons, gravity, magnetism, electricity, photons. It just doesn't matter which one I say is first, second, third, fourth. They're all becoming each other.
Handy sometimes. The other day I was at the dentist and he's getting ready with his electric drill to make holes. And I thought I better think of something fast or else it's going to hurt.
I think it's going to hurt regardless, but whatever. I think there's something at 28, so I'm going to jump ahead. So the idea was he went to the dentist. That's where he thought of the turbine spinning and the whole consequence of the copper. He made some analogies that weren't exactly perfect because he was talking about jiggling the copper, and that won't create anything. Jiggling copper won't get you anywhere. You have to jiggle copper that has a current in it, because then it's magnetic. And he left that part out. So again, he didn't recognize that first you have to turn the copper into a filter. First you have to make it a filter by putting a current in it. The current rearranges the little bits inside, essentially magnetizes the copper, and now the copper can cause electrons to move in the other pieces of copper.
Pushing is going through that space. And the only thing that happens with the cone and the paper is that circumstances have arisen which make it possible to see that these forces go through a bigger distance than just the short distance between the atoms. What?
And again, this was traditionally thought of as electrostatic, but it's again really just a question of magnetism in the end. The creation of those imbalances in charges really have to do with moving electrons, and moving electrons is creating magnetism.
What it is if you have charges like electrons that are both the same. They repel each other with a force. They're little tiny particles. They're a piece of the atom, and they
Right. So he's got that part right? But see, the key problem they have is they keep thinking about the charge of the electron, and we know that's a static thing. And what's really changing is the amount of energy trapped in here. The bent space, the gravitons, the magnetons, the tons in here are what's making the force stronger and stronger and stronger as you bring those electrons together.
repel each other with a force which is enormous. It's inversely as the square of the distance, just like gravity is inversely as the square of the distance, but gravity is attractive, and this is repulsive. And for two electrons, the gravity is so weak compared to the electricity. Electricity is so much more enormous.
Right. Well, there actually is no gravity, because all they're reacting to is their nature as a filter. They're a monopole, they're magnetic, and all the gravity is converted into that consequence, and everything they do is dictated by charge fields that they're in. And the idea of gravity has no meaning beyond the fact that whatever gravity there is, that can create charge in different locations. But electrons, there's no gravity between electrons and protons and electrons and electrons. It's just not a... They're only dealing with the force as it comes to them in the segregatable or filterable element. It's clearly gravity, but for them it's all magnetic gravity. It's all filtered gravity. So it has to be called magnetism.
Then the gravity, I can't express it because I don't know the name of the number. It's 1 with 30 or 8 or 40 zeros after the 1. Bigger is electricity. It's so enormous.
So again, it's just pointing out that the little bodies that are almost massless in their peaceful state are, again, the gravity is irrelevant compared to the fact that the electrons will trap force between them, and electrons and protons will release pressure when they interact. And that's really the force we're seeing. And that force is the same force that for us creates gravity. For us, it's gravity because we're not magnets. For us, it's gravity. Well, even a magnet feels gravity as gravity because the filter is just changing it after it goes through. It doesn't change the fact that you're going to be hit by the force. It changes what you're going to hit with the force because you're changing the force. So a magnet is still affected by the force just like we are, gravitationally. The thing next to the magnet might be very differently affected because of how the magnet changed the force. We don't change the force. We don't filter it. So we don't see the power of gravity. If we were magnets, we'd see the power.
Then if I were all electrons, well, the numbers are too big. So if there's also, however, for electrical things, other kind of charge, positive charges. An example of protons are positive. They're inside the nucleus of the atom, and they attract electrons. Opposite charges attract them, like charges repel. So you have to imagine.
Right, so he's still saying attract, and like I said, it's if you really think about attraction as a physicist, I think it's logically compelling to recognize that in many circumstances where you call something an attraction, a compression, that it's happening because of the external pressure, not because of some internal mechanism. Most circumstances where the pull is, there has to be a push creating it at its source. Alright, so I don't know if there's need to go much further. We'll go a little further.
Enormous forces where likes are trying to get away from likes and unlikes are trying to get near the opposite. What would happen if you had a lot of them? There'd be all the likes would collect with unlikes. They attract each other. And they'd get an intimate mixture of pluses and minuses all on top of each other, very close together. You wouldn't have a lot of pluses anywhere because they repel each other. They'll all be compensated by minuses very close. And you get these little knots of plus and minus. The reason that the knots don't get smaller and smaller is because they are particles and it's got quantum mechanical effects that we won't.
Okay, so quantum mechanical effects we won't go into, which really means the protons, their range of influence, although their strength isn't bigger, their ability to influence it at more density is bigger. So therefore they're capable of having a broader field of influence than an electron. So having electrons in front of you would just represent having, instead of a brick wall, it's just fence posts. And there's plenty of room for the proton's influence to exceed past the electron once you go a certain distance. So the further away you get from a proton-electron combination, the more it ends up looking like just a proton. The electron gets consumed by the proton's greater density of charge. But anyway, I don't need to get into all that. So I think I've accomplished what I wanted to point out, which is that obviously this is, in my opinion, I found a unification mechanism for physics, and it just uses the things that already exist, and just the simplest part of it is just the idea of understanding that if you take that simple force of gravity, make it a real thing instead of a bent thing, or a geometric thing, or a geometry thing, or an algebra formula, and make it a real force, that force polarized can perfectly explain magnetism. And with that, now you have a carrier for the things that cause electricity to move in wires, electrons to move. They move because force pushes them. And once you do that, and once you have electricity, you can understand that the process of these electrons moving means they can shoot force, and that they can shoot it at a frequency which we call photons, and which can include visible photons, like heat. And some of them are in the heat range, and we can see that. We can see a kind of temperature created by the force going back into the ecology. The magnetic force creates the movement creates a dispersion of the force into tons of heat and different kinds of radiation. That radiation comes back as gravity as a force, and then is converted into magnetism by filtering. And that's the ecology of physics. So, I think that covers it for this edition. Thank you very much.